video, we talked about Solar Tracker. And if you don't know what that is, go back and watch it. If you still don't know what that is, you shouldn't be watching this video now.
Hey man. Yeah, so this is a solar tracker. This is the physical model that represented in the last video. Okay, so this is how it looked. It looked like the internal circuitry. So we've got the main PCB, the cap bank, the DC-DC, the power distribution board, the Raspberry Pi, the motor driver, the ADC, the current sensor, the limit switches, the LDR, and the solar panel with the encoder and the motor connected just below it. Now, this is the system we built. The FLM Solar Tracker. Spot the difference. So it's actually running right now. It's made of plexiglass. We've got it plugged to a voltage supply, 17 volts, which is the rating of our solar panel right here. Actually, it's in manual mode, so we're gonna do a little demo. So it goes forward, forward. It reaches the bound. You can't go any further because you have to reach the bound. You can't exit that. So you're gonna reverse. Left, bound, reach. You can't go any further. Now, you can go in auto mode. It updates the screen, auto tracking. Now, the fact that it's not moving, it means that the two LDR are receiving approximately the same intensity of light. So, if I hide this, is supposed to receive more light than the other, so it goes in the opposite direction. What if I hide this? It goes in the opposite direction. Now, if you receive the same intensity, it stays still. Now we've got a halt to halt the system. And we made this structure that you need to press and maintain because to make sure you actually want to set or activate the halt, emergency halt. So it displays a countdown from 30 to 0. In which in this state the system is unresponsive to any kind of input. But once the count reaches 0, then it goes back to its previous state. That was auto tracking. So I turn it to manual tracking right now, and then it is showing okay because the battery level is above 20%. So I'm gonna reset the system. Display system rebooting. Do not press power button. Displays a count of 10, and when it reaches 0, it's gonna restart.
Of our solar tracker, we have the cap bank, which we use non-capacitors rated at 2.7 volts at 100 farads, and we use 9 of them in series, which comes up to 11 farads. And right here we have the DC-DC, which shows us the voltage in, and also the one behind it is another DC-DC rated at a higher amp. Is rated at 8 amps, and also we have the ribbon cable right here, which connects this board to the Pi, and over here we have our motor driver, which drives our DC gear motor up here, which makes the panel move, and also we have the analog to digital converters back there, which gives us analog values used for the sensors, like the current sensor, which is right here, and the two LDR sensors, which are mounted on the solar panel.
So why do we care? Well, solar panel gives you free energy, right? Well, in this particular case, it gives us 17.5 volts approximately of free energy. We have just so conveniently have this power supply, which is providing about 17.5 volts, as you can see, to the input of this whole project. So just to prove it to you, I got a meter here. We'll measure it, and it measures 17.5 almost volts, or a little over. And what this means to you, so if you put in this free energy that the solar panel gives you on a sunny day, then you will get, for instance, USB output, which you can charge your devices, your tablets, or whatever else you'd like to charge. There we go, that's kind of what went out.
13. Wow. Track the sun, baby. Yes, yes. So legit, man.
Right, that's good. Get it from as me too, man. I can't believe I am working after all this. Take some good videos, Brigman.
Sure, man.
Please, man. Please.
Please, please,
Please, man.
please.
Let's go up.
14 volts. Wow.
These can get up to 17. That's awesome, especially.
Wow, 14.3. 15.
15?
Wow.
So that means it's actually reading 17.
Yeah.
Yeah, that's right.
It's still going up. 15.2.
Auto tracking in action, man. Ash. So legit.